Okay, so now we have this map of North Miami, and we're going to calculate the UTM coordinates of some arbitrary building on the map, right? So here we have here we have a little building, right? And here we have a UTM line. And if we follow the UTM line up here, we see that the easting is 579,000, right? So where were we? We're here, right? So if we just take any ruler and we measure directly east from the UTM line to the building, we get between 16 and 17 millimeters. Let's say 16 and a half millimeters, right? So let's write that down, right? So 16.5 millimeters east, right? And then we're going to measure north from the UTM line here to the same building. Except I can't read the number. Oh, that's, well, I don't know if you can see that, but it's almost exactly 10 millimeters, right? So we get 10 millimeters north, right? Now, what we want to know is how many meters that is at the scale of the map. So let's start with the northing. If we take 10 millimeters, to get to the scale of the map, we have to multiply by 24,000, which is the scale of the map, right? And that tells us that on the ground, those 10 millimeters represent 240,000 millimeters. But we want to add these to the UTM coordinates on the map, which are in meters. So to convert the millimeters to the meters, we divide by 1,000, right? And we get 240. So the northing for that particular spot, which was here, right? This is the north coordinate. We follow that out to the edge of the map, and it tells us that was 2,872,000 meters, right? 2,872,000,000 meters, right? North, plus 240 meters north from the line to the building, and we get a total of 2,872,240 meters, right? And that's our north coordinate. Okay? So let's do the easting, right? So the easting was 16.5 millimeters, right? Times 24,000, which is the scale of the map. And so the 16.5 millimeters we measured by hand with a ruler on the map really represent 396,000 meters on the ground, right? If we were to, not meters, millimeters, on the ground. So if we were to go out there and walk that distance, it would add up to 396,000 millimeters. But we don't want the measurements in millimeters, we want it in meters. So to convert, we divide by 1,000. And we get 396 meters. Remember that the distance between the UTM lines on the map is 1,000 meters. So if you get a number bigger than 1,000 meters, you should be very suspicious. Maybe you didn't measure from the nearest line, for example, right? But regardless, right, we started out by measuring east from, that's our house, here's the line. We follow that line up, and it takes us to 579,000 meters east, right? So we started at 579,000 meters east, and we're going to add 396 meters further east. Sorry about my camera work, it's not too good, right? And we're just going to add those together, and we're going to get 579,396 meters east, right? So our final coordinate is going to be 396 meters east, 2,872,240 meters north in zone, what was our zone? Zone 17 north. The only reason I know that is because it says it on the legend of the map. I didn't deduce it or measure it. I just have to read it off the legend of the map, right? I lost the top of my pen somewhere. So this is a complete and correct UTM coordinate, right? And if I give you a map and ask you to calculate it, you should be able to do that. In other words, if I give you a map that shows the UTM grid and ask you to calculate a coordinate of an arbitrary point in the grid, you should be able to do this, right? If I could give you all transparencies with nice little scales on them, I would do that, but we don't, they're expensive. So we don't have enough, and we often don't have access to them. As I say, when you most need them is when you least have them, right? So I have a bunch in my office. I never seem to have them in the field when I actually need them. One other issue that arises frequently in this process is that many of the USGS maps do not have the UTM grid printed on them. They only have tick marks. So they don't, unlike the map we were just looking at, which is a more recent map. Fortunately, the newer maps do have the complete grid printed on them. But the older maps just have tick marks printed on them. And so you have to actually take a pencil and draw the lines on yourself using a meter stick, which is why we have meter sticks here. So let me show you how that's done. So here's a USGS topo map of Boca Raton. So I'm actually standing in this map in a sense, right? And if you come very close, right? Here's the, up in the upper left corner, here's the complete UTM, coordinate, right? What is it? 2,917,000 meters north, right? And as we move south, there's one missing. There's a tick mark in here, but it's not labeled. The next labeled one is 2,915,000 meters north, right? But you'll see there's no line printed on the map. So the problem is that if you want to measure the, UTM coordinate of some point over here, there's no line to measure from. So what you need to do is you need to take a meter stick, right? and find the tick mark here, and then find the corresponding tick mark on the other side that has the same coordinate, the same UTM coordinate, and draw a horizontal line there, right? And then you can measure from that line to whatever point you're interested in, okay? That's an additional complication that is disappearing as they print newer and newer maps, but it's been around for a long time, right? So I imagine many of you have questions. There are a number of videos and printed guides to how to do this. I will post one, or have posted one, on the Canvas site called UTM USGS. And I think I also have another somewhere, and I will post that as well. Okay? And they explain how to do this, more or less as I've explained it. Okay? The next topic we're going to talk about is the public land survey system. But we'll start another video to do that.